How's it going, ladies and gentlemen? Mr. Donahue here again. This time we're going to take a look at some practice problems for 19.1 spontaneous reactions. So objectives being describe reactions in terms of spontaneity, reversibility, and state functions. So number one, which of the following statements are true for a system at equilibrium? So at equilibrium, is it true that the forward and reverse processes has stopped? No, right? So whenever we have an equilibrium, we draw a double arrow, right? It could look kind of different, the different ways to draw a double arrow, but they're both saying one thing. They're saying there is a forward process and a reverse process. So it hasn't stopped. It's like running on a treadmill. You may not be going anywhere, but there's a forward process of you running forward and a reverse process of the treadmill moving backwards, right? So it's not A. What about B? Neither the forward or reverse reactions are spontaneous. This is true, right? Neither one of them is going to be spontaneous. There's no change overall. So the forward or reverse is not favored one way or the other. All right, C, the forward process is spontaneous, but the reverse process is not. That's not true, because if it was true, you'd just go forward. D, the forward and reverse processes are both spontaneous. No, with the definition of spontaneity, it's not, right? Neither one of them are spontaneous. The reverse process is spontaneous, but the forward process is not. Definitely not true. All right, so of the following, which is not a state function? Remember that state functions depend on just the state that they're in. How are they right now? Not how did they get there? That doesn't matter for a state function. It's just what is it like right now? So internal energy is a state function. It just depends on where it's at the moment. Enthalpy is also a state function. It doesn't matter how it got there. It just matters how it is right now. Heat exchange is not a state function. Heat exchange does matter. How did it get to where it's at will determine how much heat was exchanged. Entropy is a state function. It just depends on how it is right then. And then same with temperature. It just depends on the state of its being, right? Number three, a reversible process is a process that blank happens spontaneously. No, that's not a reversible process. What about needs to be carried out at low temperatures? No, it doesn't need to be at low temperatures, and it doesn't need to be at high temperatures either. What about is spontaneous in both forward and reverse directions? No. What about can be reversed with no overall change in either system or surroundings? Yes. All right, so that is the definition of a reversible process. If you can just, hey, I added 10 joules to my system. If I wanted to get back to exactly how it was before, I could just remove 10 joules and it's exactly how it was. It's reversible. So things like phase changes will be reversible. Which of the following statements is true? The processes are spontaneous because they occur at a noticeable rate. That is not true, right? So rusting is a spontaneous process, but you're not going to notice it. If you're looking at it, you're going to be like, wow, watch it rust, right? But over time it will, but not at a noticeable rate. What about spontaneity can depend on the temperature? This is a true statement, right? So melting of ice, if you start with an ice cube, when will it turn into a puddle? Well, it depends on the temperature. If it's warmer out, that process will happen spontaneously. Or what about C? Processes that are spontaneous in one direction are also spontaneous in the opposite direction. That is not true, which means choice D is not true as well. All right, so I hope you found that helpful. I'll see you in class. Okay, bye.